So good morning, everyone. We're going to start a conversation about the strength of acids and bases. This is just the beginning of the lesson. A lot of the lesson is actually going to be self-taught. I'll get to that at the end. But I want to remind you, we have talked about the strength of acids and bases in terms of, we've mentioned the vocabulary. Today, we're going to look specifically at what the vocabulary means. What does it mean to have a strong acid or weak acid? What does it mean to have a strong base or a weak base? So that's what you need to figure out today, is the idea of the strength of acids and bases, and then how we would measure that. How can we have a way of knowing, without just memorizing a massive list, how would we have a way of knowing how strong or weak an acid or base is? So I want to start with review, because like I said, we've already started with using the vocabulary. So before we dive into what the vocabulary is really telling us, so you've got those numbered off there at the front of your paper. We do know acids will ionize to give us H. I guess I should specifically say H plus, hydrogen ion. Same thing as a proton. Same thing as acids ionize to make hydronium ion. So that was one of our definitions long ago, Urena's definition, that acids give us hydrogen ion. We had that. That should be reviewed. So since it's been a while since we mentioned it, like 4 whole days, there you go. Converse to that, bases make hydroxide. So again, they're going to ionize, they're going to break apart, and they're going to form hydroxide ion as they break apart. So the solution they're in starts getting more hydroxides roaming around in it because they are ionizing to make that hydroxide ion. And from really long ago, but hopefully you remember me doing this, I stood up here with all my light bulbs and we tested our various solutions to be electrolytes. And we did spend time with acids and bases during that demonstration. Strong acids and strong bases, we found at that time, were strong electrolytes. So I'll remind you of our proof. What was the proof that something was a strong electrolyte? Yeah, we get a bright light, meaning lots of electricity is conducted through the solution. And I started that whole demonstration telling you there were 2 things necessary for that to happen. Something needs to dissolve and something needs to ionize. So catch that out. Acids ionize to make hydrogen ions. And so strong acids must ionize really well because they're strong electrolytes. And bases ionize to make hydroxide ion. And so a strong base must be ionizing very well to be a strong electrolyte. Then I tested a few other acids and bases, and we found they were weak. We did discuss at the time that acids and bases are dissolved. They have to be dissolved to even be acids and bases in the first place. So if weak acids and weak bases are weak electrolytes, that must mean they are not forming a lot of ions. They are not ionizing much at all. Just a little bit. Only a little electricity can travel through. Okay. And so I said this before, But a final reminder, you'll now have it in your notes for future reference, that electrolytes are things that have ions in the water. So our definitions of strong acids, strong bases, weak acids, weak bases, all come down to ions. They were electrolytes, either strong electrolytes or weak electrolytes, because they were making either a lot of ions or a little bit of ions. So it all connects together. We now know what acids ionize to form, what bases ionize to form. And we know there's two ways they can go about that. They can form a lot of ions, they can form a little bit of ions. So electrolytes are things that have ions in them. A strong electrolyte then has a lot of ions, a weak electrolyte has just a few. So what we're going to conclude. We're going to conclude that strong acids or strong bases are strong electrolytes because they make a lot of ions. Again, I remind you, acids and bases have to be dissolved to be acids and bases. So we're not testing that part. When we talk about whether acids are strong or not, we are discussing then how well they ionize. So a strong acid, a strong base are strong electrolytes because they must make a lot of ions in the solution. Now we're going to make a conclusion for weak acids and weak bases. If strong acids and strong bases make a lot of ions in a solution, guess what weak acids and weak bases do? Yeah. Weak acids and weak bases are weak electrolytes because they only make a few ions in the solution. Again, they will dissolve. We're not putting that up for debate. But when they are placed into water, weak acids, weak bases only ionize a little bit. So knowing the strength of an acid and the strength of a base is to know how well it ionizes. That's going to be the key. That's what we're trying to connect. How well it ionizes tells us whether it's a strong acid or a strong base, or a weak acid and a weak base. Okay. So as I mentioned at the beginning, today has a lot of pictures because the best way to consider whether an acid or a base is strong or weak is to picture what's going on with the ions. So a strong acid or a strong base will ionize completely. Now in chemistry, we say 100%. It may not be exactly 100%. It may be like 99.9, 99.8. It may actually even be like 98%. If you really want to know the percentages, you take AP chemistry, that's something to study. But please believe me on the conclusion here. Strong acids or strong bases ionize either completely or very, very close to completely. Noticeably close to 100% ionization. What this is going to do is cause the pH numbers to be far from 7. And I know we have not talked about pH in depth yet. That is actually next time's topic. But I'm going to start introducing pH today. So something for you to start getting used to is the idea that we will find our strong acids and our strong bases far from 7 on the pH scale. And so you can see I have a picture here. And on the left, here's the before situation. I have HCl, and I'm going to put it in water. And we're not going to debate, is it going to dissolve? Because again, for an acid to be an acid or a base to be a base, they're going to dissolve. That's part of their characteristic of what they are. So I put it in the water, and notice, how many acid molecules is this picture showing on the left? 3. All right. When it's placed in the water, and I get to the after picture here, so on the right now, how many of those molecules have ionized? All of them. You see how all of them have broken apart into ions, and they were nice in this picture. We even labeled the positive and negative pieces to show us that yes, they are ions. So all 3 of the 3 have ionized. That would be a picture that would show us it's a strong acid. I know it's an acid because it tells me HCl. I know it's a strong acid because I see that it's ionized. All 3 out of 3. Now let's flip to the back of your paper and let's look at something that doesn't ionize all the way. A weak acid or a weak base will ionize less than 100%. And I wish there was a better way to say this, because when I say less than 100%, I usually mean like way less than 100%. A whole lot less than 100%. If strong acids and strong bases ionize close to 100%, really like weak acids, weak bases ionize close to 0%. For some of our weak acids and weak bases, they won't even make it to 1% ionization. Like in AP chemistry, we have to deal in decimals of percentages for how much they ionize. So the good news for us is there tends to be a very obvious division between the strong acids and the weak acids because there is really no in between. We do not find acids at 94% and 93% and 92% and all the way down. We have like close to 100% and then maybe close to 2%. Big gulf in the middle. It should not be difficult to see the percent ionization indicate whether it's a strong acid or a weak acid because there should be a drastic difference in between. So in this picture, which I also put on your notes, we got an acid. It tells us it's acetic acid. So here's our acetic acid molecules. They're kind of like blue purple here. Real fast, how many molecules are about to go into the beaker here on the left? 10. How do you know? Exactly. So we just count, okay? So like maybe on the test, if I show you pictures to count the molecules, just saying. So I got 10 molecules, they're about to go in the water. Now they are going to dissolve, that won't be up for debate. Now I did you a favor, maybe you want to do this on your paper too. I circled 2 things in one circle. Why did I circle these 2 individual little spheres? This is the one molecule that I have. This is the one that broke apart, right? You see how all the rest are still together. Now this is actually stronger than real acetic acid is, but we're not going to worry about that. What is the percentage of 1 out of 10? 10%. And again, this is even really an exaggeration of how strong acetic acid is. It's not even this strong, but they can't show the number. I mean, you would be able to see all the little spheres if they try to show the real numbers. You get the idea. Much less than 100% ionization. Okay. So again, it should not be something you have to worry about debating. Is this strong enough to be strong, or is this low enough to be considered weak? It should be an obvious difference. So a strong acid ionizes completely or almost very close to completely, and then a weak acid obviously does not. And I do want to take a moment before we move on and discuss that weak acids, weak bases will cause the pH numbers to be close to 7. That is, they will be neutral or close to neutral. Which is, you're about to continue to explore the idea of pH, you're going to see strong acids, strong bases are obviously far away from neutral. I hope that makes sense. So if you're weak acids, weak bases, they're relatively close to neutral. I hope that makes sense. So we're going to be exploring this a little more in just a moment, working some pH into it as an introduction to pH, and hopefully you'll see how all the pieces fit together. Before we leave, I want to be sure that you don't get confused with vocabulary, because it is a very common place that students confuse strong and weak with concentrated and dilute. And this confusion mostly comes from the idea that the world says it wrong. People out there in everyday conversations says it wrong. So it's a matter of being sure you in chemistry are using the right words so that you're communicating correctly. Concentrated and dilute is something we discussed in the solutions unit. Generalized for me, look at the column, both top and bottom, that says concentrated, and then the column, top and bottom, that says dilute. What can you generalize about concentrated compared to dilute? Tell me about concentrated. What do you see in concentrated? There's just more of it. You see more of the stuff. Exactly. What do you see in dilute? Less of the stuff. All right. So that is absolutely concentrated and dilute. That is that molarity or that percent by mass or the mole fraction that we calculated in our solutions unit. That is concentration. How much stuff is in the water? Now we're going to go across the rows. Here is strong, and these are all acids, and it works the same with bases, so I'm just showing acids. Look at the left versus the right. There should be something in common. We know that the amounts are different. That's not what we're looking at. That was concentrated and dilute. For concentrated, look at the bold letters. The bold letters are the not ionized pieces. And what do you notice? Not many little not ionized pieces, right? Most of them have ionized. That is strong. Now I can have a concentrated strong acid and I can have a dilute strong acid. Concentrated strong acid is most definitely nasty. Do not go near it. Not something you want to be around. Dilute strong acid is something I would often give you in the lab. It's still a strong acid, it's still going to have the properties of a strong acid, but because it's dilute, it makes it safer. You have a little more time to wash it off yourself before damage occurs. A little more time. You don't just go walking around for 20 minutes going, you know, maybe I spilled something on my hand, I don't know. You wash it anyway. And then look at the row that says weak. And again, look at the bold. And what do you notice about the bold letters in both the left and the right of the row that says weak? There's a lot of bold, a lot of not ionized pieces. What is a weak acid? Something that does not ionize well. So you can see over on the right, very easy to see, only like 3 pieces have ionized. Here on the left, it looks to be about 9 pieces maybe have ionized. Look at all those pieces that have not ionized. So I can have a concentrated weak acid, and that's still not necessarily something you want to be around. But when it comes to the properties we expect from acids, it's not going to be as extreme. And then we can have over here dilute weak acids, which is hopefully the acids you encounter in everyday life. We know citrus fruits have citric acid. I hope that ends up being dilute weak acid, which is part of the reason that we like citrus fruits so much. They're just juicy. They have lots of water content that makes the acid dilute. And I do know citric acid is a weak acid. It does not ionize them, so that makes it safe to eat. So hopefully the things in everyday life can tend to be here where it's dilute and weak. So that's the contrast between concentration and strength. I want to say this very clearly one more time. No, I didn't mean to push that, sorry. There is no connection between concentration and strength. If you know one, you do not know the other. Just knowing it's concentrated, you don't know whether it's strong or weak. Just knowing it's strong, you don't know if it's concentrated or dilute. Do not connect the two. There is no connection between strength and concentration. Unfortunately, the world says it wrong. People will often say things like, wow, that's a strong cup of coffee. But what they're saying is that's a cup of coffee where the coffee has ionized well. That's not at all what they mean. They mean, wow, that's a concentrated cup of coffee. So please don't let previous usage incorrectly of these words throw you off. There is no connection between strength and concentration. Knowing one, you do not know the other. Please be careful about that. Okay, so as I've mentioned, there is an assignment that's actually going to start introducing pH, and it's introducing pH based on this idea of strength of acids and bases, because it is all related. This is a foldable. Now, I learned long, long ago that it is worthless of my time to stand up here and direct you all how to make a foldable, because I end up having to repeat myself 10 times, and some students don't ever get it made, because I'm still stuck repeating it over and over and over again. So there is a video right here that you will watch at your own pace, so that you can pause it the moment you need to pause it. You'll watch that at your own pace, and you'll make a foldable. Once you make the foldable, and this is an assignment, this is not extra. This is not a review tool. This is how you're going to learn the connection between the pH scale and concentration. This is a purposeful part of today's assignment, so be sure you do that. You're going to watch this video at your own pace. Again, you get to pause it whenever you need to, so that you can make your folds and you can do your colors and you can, write in the numbers at your own pace. Then once you have that made, you will definitely want to be using it on this quiz. That is your assignment. So this quiz is your assignment. Yeah, we'll have some time tomorrow to finish up, but after that it is homework. So do yourself a favor. Make that foldable. That is high priority, first thing you're going to do. So you're going to get on your device. Ideally, you have some like earbuds or something to listen to it, but if you don't, that's okay. Just start blasting it in the room. We're all going to be blasting it, so it really will just be a noisy classroom, and I have no problem with that. Make the foldable and use the foldable. I really do not know how you're going to get the answers to the quiz without the foldable, because it is meant to come right off the foldable. I said to make the foldable enough that you understand the importance of making the foldable. Because again, this is not fluff. This is not We have extra time. Let's do something with it. This is a very purposeful introduction to you of the pH scale and how strength and the pH scale connect, because they absolutely do. All right, so that's what we're doing now. Students in the classroom, I have notebook paper up here. You're welcome to use for the foldable if you don't have your own or don't want to use your own. I have colored pencils up here if you don't have your own colors of any sort. It doesn't have to be pencil, it could be pen, could be crayon, for all I care. Okay, but there is a part in the foldable where colors are going to be necessary, you know, share nicely and all that good stuff. Between today and since you know we're first period, we have a little bit of time tomorrow. You got to get that foldable made and that quiz done to 100%. I'll also point out we are testing next week Thursday over this unit. So you want to be sure once the foldable and that quiz is done that you go back and take care of any other work for this unit that is not done to 100% completion. Because you want to finish the semester strong. And this test at the end does have enough points on it that if you're even in the passing range, you certainly could be at the above 85 range in time for being exempt from the final. And if you're not in the passing range, there could be enough with this test, if you do well enough, that it gets you into the passing range. Even though you'll have to take the final, you could at least have the shot of getting your credit. So grades could go up a lot. Be sure you finish strong and take care of this. Okay, so that's what we got going on. Let's take care of that foldable. Let's take care of that quiz. Let me know if I can be of any assistance.